Today's presentation is on lighting on model railways. And as you know, we've covered lighting before. So I don't intend to cover stuff we've covered before. There's a presentation that covers the technology, how LEDs work and what to expect of them and the parameters and the current draw, droppers, all that kind of stuff. It's already covered. And that's available on our YouTube channel and our website. As are these. We've covered all kind of other issues related to lighting on the layout. So again, I don't want to really cover these because you can see them on the YouTube channel. I want to cover more how we use LEDs on the layout for lighting purposes. For things like that, how do we light the entire layout or individual parts or mimic panels? But adding lighting to a layout can make a huge difference in how it's viewed, especially if it's viewed in a subdued room or at night time. The ambience you achieve can be quite startling, like that, or that. And then there's George's roadworks, which gives you a real feel of the mood around there. And then there's this one, which at first glance looks to me very, very nice. And then I stop and I think, do I really see that amount of light on roof in real life? Look at the back there, the number of really, really bright lights. Is that realistic? So the first thing we want to think about is quantity and brightness. We don't want a Christmas tree. We're trying to make a model railway as realistic as possible by adding lighting. And I find in lots of model railway exhibitions, you've either got no lighting at all, or they've got one master switch and all of a sudden you get that Christmas tree, there's lights on everywhere. So what's the best approach? An ideal scenario from Keith and his layout, where the shops and the houses, as you can see, have got subdued lighting, whereas the cinema, as you'd expect, is gary and bright to attract people. He's using lighting effects to achieve what he wants to achieve there. So when we come to lighting, there's ones that are triggered. What I mean by that is, if the train is coming near a crossing, then the lights on the crossing, the lamps will flash. Or a train comes into a yard and the yard light comes on. Or a loco goes into the repair shop, and while it's in the repair shop, you get the welding effect. There's nothing you need to do. It's triggered by other events rather than you throwing switches. And then there's ones that are completely automatic, like traffic lights. Nothing triggers them. You put power on and they go through the traffic light sequence. Or you get the random lights in a building, or a little factory or a village. Various lights come off on the houses. Or you have a day and night sequence. And I find the welder again, because you may have the welder triggered, or you may just have it that it just cycles on its own. There's somebody repairing at the track side, and periodically it just comes on and flashes. We don't have to throw a switch, in other words, to bring on lights unless we want to. And I want to make, from the beginning, a distinction between lights on the layout. There's lights that are there to illuminate the whole layout or parts of the layout, like yard lights and so on. They're there to illuminate other things. But then there's lights that are only meant to be seen. You don't expect the traffic lights to light up the street. They're to be looked at. Let's look at some examples. You want to illuminate the whole layout, illuminate a whole building. and you're seeing the results of the light shining on something. But to be seen, signals that well now spoke about, traffic lights, the conductor's lamp, and so on, are there to be looked at. They're not there to illuminate something else. And that means they decide how bright the lights are and which lights they choose to do it. What have we got in light sources? Well, it wasn't that long ago, and I think there still are some layouts that you'll see that illuminate the entire layout using fluorescent tubes. The large gantry above the layout, and that gantry supports fluorescent tubes. They've got the advantage of providing an even light, of course, as I say, but they are fragile, especially if you're trying to transport layouts back and forth. They're not the ideal. And of course, the other problem is they work at mains voltage, which we don't like to have close to our layouts. Some replaced the tubes with halogen spotlights. And generally, they are what they say. They provide a pool of light on your layout rather than an even light. And they get extremely hot to the touch and can be fragile. So although these were popular, they tend to be replaced now with various LEDs, which you can see work at a low voltage, roughly approximately 3 volts roughly. And they come in all shapes and sizes, right down to tiny surface mount pieces and even smaller pre-wired with microliths wire. I said they vary in brightness depending what you choose. They're measured in millicandelas, thousands of a candela. And you can get them up, as you can see at the bottom. Some of the white ones can go up as far as 100,000 millis. This seems like contradiction. So we're talking about 100 candelas of light, depending on what you want to illuminate and how bright you want the light to be seen and what viewing angle they have. We'll come to that later. So the tiny surface mount versions, as you can see, got a small amount of light. The middle one is a 10 mil rather than usual 3 or 5 mil LEDs, much brighter. So it's intended to illuminate something. And then if you go to the one on the right-hand side, we're talking about quite a bright light, producing quite a bit of heat. Therefore, it's mounted on a piece of metal that's meant to be bolted and turned to a heatsink. So you take your choices. Very popular now, of course, are LED strips. You can buy them in 1 foot or 2 meters, 5 meters, and so on length. And you can cut them to the length you need for your own use. I thought I'd bring in this LED panels. If you've been to my house for the workshops, you'll know that I use one of them over my work area because you have very bright and very even light. And then they have the ones that are called COBs, which just means chip on board. There's a floodlight there working at 50 watts. And you can see in the center, if you can look closely, a whole collection of individual LEDs all in one board, hence chip on board. They're manufactured as a cluster, in other words. You don't have to have it in the domestic floodlight. You can buy them in any shape and size on eBay or any of the Chinese websites. And the beauty of them is that they work on 12 volts, which is very handy for what we're doing. No droppers, don't have to calculate droppers. You just put 12 volts on them and they light up. and you can place them in strategic places, especially the smaller ones. Right, so let's look at how do we illuminate the entire layout. So we might want to have complete illumination. We might want to have just backlit scenes, skylines, and so on, various lighting effects for different times of day and different types of weather. There's the old traditional layout using fluorescent tubes. But look at the size of the gantry there. You can now get lead replacements for fluorescent tubes. You'll see on the right-hand side there, it's a drop-in replacement. And it means they're less fragile. They're not going to be damaged in the same way potentially as fluorescent tubes. However, they still work at mains voltage, which is a problem. And they're still pretty heavy. And they only come in cool white if that is an issue. If you're not replacing fluorescent tubes with lead versions, you can buy what you see on the left-hand side, which are lead battens. They give you an even light, and it's already encased in its own body. Relatively cheap. But of course, the problem is, again, you're still working on mains. And it's still relatively heavy. So that has led to people using lead strips for overhead illumination. Normally buying them in 5-meter lengths. But within that 5 meters, you can get different densities. You can buy a 5-meter length that contains 300 LEDs along that 5 meters. Or you can buy ones that have got 600 LEDs distributed across the same 5 meters. Of course, they work at 12 volts. And as you would expect, if you double the amount of LEDs, you double the amount of power. But they have a wide viewing angle, which is good. And they're available in different colours, which is ideal for making different day and night and weather effects. They're advertised as being self-adhesive, but from experience, I prefer to add additional adhesive or glue gun or whatever just to make sure, because they can tend to peel off. You can cut them anywhere. You'll see those little tabs. There's 2 sets of tabs there on the left and right. If you cut right along the middle of that copper tab, you get a set of 3 LEDs or 4 LEDs with the droppers, depending which ones you get. And that means you can buy a 5-meter length. If you'll need 3 meters to illuminate a section of the layout, you can use the others inside buildings or whatever. There's an example of somebody using lead strips under the valance of the layout. It's a multi-level layout. There's another one, and you can see what a beautiful, even light you get from lead strips. In that case, it's cool white, so it's meant to be a bright day. There's more about it if you dig out that YouTube reference. Now, I said earlier, we can use lighting to achieve different times of day, different moods, and so on. We've got that picture. The only downside to it was that the lights were all cool white, which doesn't seem to be in keeping for the kind of house it was. You don't tend to have fluorescent lights in every room of your house. But on the other hand, we've got little stars twinkling there, which I think he's achieved. I'm not sure, but I think he's achieved it with fiber optics. But having different coloured LED strips allows you to have different weather conditions and different day conditions. our layout looks like that during the day, but if we get a storm, it looks like that. It dulls down because we've got cool white LED strips for during the day, and we've got warm white and blue at night to give you the nighttime effect or a storm effect. Where's the best place to position LED strips then? Well, you can't have them overhead behind some sort of valance because you don't want to see the LED strips themselves. You want them to be illuminating the layout, so you have to have some valance to cover them. Or you could have them behind the buildings, shining onto the backboard. Like this. Here's on the right-hand side, we've got the backboard, and then we've got the green lump. There could be trees, could be hedges, could be hills, whatever you want there, and you put the LED strip between them. And the LED strip is now shining up. And that saves you having to have a whole separate construction with a valance looking down the way. You can illuminate the back of the layout. Or if you've got a building, you can have space so the light angles. And again, they can be in behind a building, in behind a hill, or whatever. Coming to buildings themselves, we want to illuminate buildings. They do that for factories, offices, and so on. There's all kinds of places you would like to light up, not necessarily all at the same time. Here's a good example of it. Again, you'll see mixed lighting. The shops tend to be using fluorescent lights, whereas the rooms upstairs are traditional lighting. There's a nice effect where we're using the light to illuminate something, the inner part of the building, and even shadows coming out the way. Lovely effect, I thought. Again, back to Keith's one. To mount LEDs, well, we can solder them, or we can simply plug them in. You can buy holders, as you see on the left-hand side, the green LEDs into an actual LED holder. Or we have those connectors ourselves with the male and female. The spacing on the female will happily take a LED as a push bit. If you have to solder, just to remind you of the 3-3 rule, which says you shouldn't ideally have soldering iron on the pins for any more than 3 seconds. Otherwise, the heat might transmit up and damage inside the LED. And the 3mm one is, if you have to bend the legs of the LED, don't do any closer than 3mm from the case. Otherwise, you're liable to crack and damage the case. So we're interested in putting these into buildings. We have to think about how we're going to get the power to them. We have to think of making a light-proof structure. We don't want leaks between the roof and the walls, for example. And more importantly is future access. You don't want to be putting lights into a building and then sealing the building and then gluing it to the baseboard. And if something goes wrong, you can't get in to change it. So you've got to bear in mind when you're putting lights into buildings, how can I get back into a future date if I have to? If you're going to solder, there's lots and lots of ways to mount them. You can connect them, for example, to an existing device, such as the contacts of a relay. You can glue gun them, you can tape them, you can staple them, you can have brackets, you can use chalk blocks. There's all kinds of ways, depending on how you want to go. When it comes to illuminating windows, again, you have a choice of warm or cool white. There's that building again I thought was too bright on the right, while the one on the left It's just about right for the correct ambience. And you want to make sure that some of the rooms are not lit. You very rarely walk into a house and find every light in the house is on at the same time. And if you're doing it as a whole village, then you want lights to come on off at random. I made a kit for that as a cover. What materials you want? Well, it depends on whether you want to be transparent. I know some of the members put a lot of time into detail inside the building. So you'll see a shop and you'll see inside the shop. Or you'll see a signal box and you'll see them, the signalman in the box and so on, in which case you want to use transparent material for windows. If all you want to do is get a lighting effect, then a whole range of different materials can be used to soften the light, make it translucent. Paper off suites, the wrappers, or masking tape works well, invisible tape works well. Or if you have to use perspex, then you can lightly sand it so you get an opaque light from those windows. It depends on whether you want to see the contents of that building or not. Light leakage. Well, we have to make sure that we use various partitions. So if you put a light on the ground floor, you don't want light leakage to be seen on the upper floors. So you have to put card between it or between individual rooms or box off areas to make sure that there's no light leakage. Again, where would you position a lead inside a building? Once more, it depends on whether you want to see the contents of the building or not. I've got two different examples there. The one on the left is where you glaze the window to be opaque, so you only see the results of a glow from that window. If you want to see the contents, then you put it, as you see on the right-hand example, up the top, out the way, shining on the back. You might want to always do the one on the right anyway, because depending on what light source you use, that left example, although it's illuminating the window, if you look in, it might be seen purely as a spot rather than an even glow. Like that. There's two examples. The one on the left is a standard white LED, and it gives you a spot of light, a pool of light rather than even light. And what I've done with the right-hand side one is I've got a small file, and I've filed down the front bevel of the lid. And the effect, as you see, is that it distributes the lights much more evenly. And you can buy wide-angle lenses. The one on the left there, you can see, is a much better pool of light than the one on the right. Unless you're using the one on the right to illuminate a part of a station or whatever. If it's to illuminate inside buildings, you want to have something with a wide angle, a top hat type LED. There's another method of getting diffused lighting. Glue gun stick, and I've put a lid in each end. When you illuminate it, you get that effect. Great for diffusing light. I'm using it to diffuse two. You could just use a smaller piece to diffuse one lead if you wanted to. Right. And then there's individual effects, like you want a lighthouse. Well, you can actually buy a lighthouse kit for 17 quid, or you can buy our pocket money kit from the Merg website. Our one, much, much cheaper and more versatile, because it has 7 different patterns depending what length you put in. And that gives you 32 different UK lighthouses. So it's much more adaptable. And one of the other options is to make it a warning beacon that you get in the top of high flats and top of cranes and so on for aircraft warning. Right. Let's look at urban lights then. All kinds of examples, largely ones that are meant to be looked at, apart from maybe street lights. You can buy them relatively cheaply from China, but they tend to come, as you can see, in standard formats. If it suits you, they're very reasonable. But on the left-hand side, you can see one that I've just made up myself, not painted, of course. I'm just using a piece of copper tube, putting the lead on the end, putting a washer on it to simulate the holder. And when it's painted up, you've got your own lamppost. Difference being that the decorative part can be anything you want. You don't have to have the ones that are ready-made, depending on what shapes you particularly want to have in your layout. Again, you can have wall lights, and you can pay £7 a pop for them, or you can make them, as you see on the left-hand side, just using an LED, bending the legs, and putting them through the wall and soldering them up. Much, much cheaper. Pennies compared to pounds. Other kits we have available are the dual LED flasher. It just flashes two LEDs off and on. It could be the recovery vehicle you see there, or it could be the crossing militia beacons you see there. You can buy ready-made LEDs that flash, but the problem with them is they're a fixed frequency, in this case 1.5 hertz. And if that's too slow or too fast, you can't change it. We've got traffic lights, four-way traffic lights, very cheap compared to the commercial ones. In fact, ours is better because you have a choice of the UK pattern or the continental pattern by changing the link. And a good friend, the random lights again, very cheap. I can switch 10 different LEDs off and on randomly. And there's a little cameo from one of our demonstration layouts, the welder underneath the vehicle. We could buy them commercially, £15, £18, or we could spend £2 odds and buy a little kit. And it's got the benefit of the afterglow. It fires up two LEDs, one white one to be the arcing, and then the red one to be the afterglow as the job cools down. And it can be used in all kinds of urban locations, workshops, garages, etc. It contains other options as well. There. There's the welding, and there's the afterglow. So it flashes, and then the job cools down. Then, of course, there's the LED dimmer. If you want to use a pot to dim a whole chain of LEDs, you can do so for £3. If you want to add to it, the schematic on the left is the standard kit to dim one strip of LEDs. But if you add another transistor, we can do a separate strip, such that when you dim one down, you're raising the other one up. Why is that useful? Well, that means you can have a daylight strip and a nighttime strip. And you can gradually use the pot to switch between day and night and then back to day again, manually. So you can take the standard bit and add in a few more components. Right, moving on now to what's happening at the line side. Lots of options. Let's start with twinklers. On our layout, we've got the guys having a tea around the brazier, but it could be an ordinary fire, could be a campfire, could be the ash piles, could be gas lamps sputtering, and so on. Again, you can buy them. The cheapest is £8 up to £32, or America can do it. Or electronic candles, which twinkle. They're meant to be a flame effect, and we can use them. We simply take them out of their case and put their own power on them. Again, you can buy LEDs that will do that. And lastly, let's look at LEDs in their use in mimic panels. What can you do? Well, they can tell you what way you've set your point with two lights, one to show branch and one to show main. They could light up to show track occupancy. That piece of track is occupied as a train sitting in that station or that siding or whatever. It can be used to let you know what section of your track is powered if you're not in DCC. So we can fit these LEDs to help us on our day-to-day running of our layouts. And some of these LEDs can be useful in that regard. For example, you can get ones that are triangular or rectangular, which will help you point the way to show different directions. In my layout, I simply drill a hole and push fit a LED through them, but you can buy proper mounting pieces, either in plastic or in metal. The metal ones give the more professional finish, cost a bit more, of course. And again, they can let you know lots of information. Somebody asked about how can you use one switch to do two things. It's meant to switch the point and either illuminate one LED or another. So you throw the switch one way, you light one LED, you throw the switch the other way, you light the other LED. You can use a single pole double throw switch. With the switch in that direction, you get 5 volts here and you get 5 volts up the top, so the LED won't illuminate because there's no potential difference. But 5 volts here and 0 volts there means that the lower LED will light. But when the switch is set to 0, you get 0 and 0 across the green LED, so it won't illuminate. But with 0 and 5 volts across the red LED, it's going to illuminate. And the same change of polarity at the switch will set the servo controller or inputs to EasyBus or C-Bus or whatever to operate points. So one switch sets a point and also tells you which direction it's been set in. Simple as that. Fibre optics are not commonly used on model railways, but they've got their place, especially in situations where you're tight for space or awkward situations, where it'd be difficult to actually mount a proper LED. And there's some examples there. You put light in one end of the fibre
and it bounces down the sides of the fibre and comes out at the other end.
Generally speaking, if you're using a single strand, you're not going to get much light, so it's not intended to illuminate things. It's to be looked at in awkward situations like the miners' helmets, guards' lanterns, and so on. The ends must be flat to get the maximum light transfer. If you're really keen, you can actually drill into the lead body if you're very careful and don't go too far, and get the maximum light transfer that way for a single strand. It takes a bit of preparation to get the best from it, but it's very useful. And the benefit is because they can be, to some extent, go around curves and so on, they can go under roads, under grass, under the track quite happily. You can retrofit them in a lot of cases without lots of extra work. And because they're fibre optic, they're free from interference. So there's no passing train going to make the light flicker or whatever. But they're meant to be viewed on their ends. So there's an example. I've got a light source between my finger and thumb, and at the other end, I've used a soldering iron to flatten the end. And I get that effect as you see there. If I then put the filament iron on the side of the piece of fibre and flatten it that way, I get what you see there. So it depends what your use is, how you would handle it. Or you can just simply have it viewed end on for a tiny light. And the most modern implementation of lights now are neopixels. I won't go into it in detail, that's a whole different discussion in itself. But the benefit of these are that they can come in different sizes. You can wire them together like that, with only 3 wires between them, 2 for power and 1 for a signal coming in. The downside to this is it involves programming. Everything I've spoken about before up to now, a simple switch or a simple kit will do it. These have to be programmed. But each one of these LEDs gets a signal coming in and then send it back out again. So you'll see that purple connection as an input and then coming back out again. And that's infinitely almost extendable as far as my layout's concerned. You can use a couple, you can use 20, you can use 50 and so on. And it's all to do with programming to which one you light, but not only which one you light, but which colour is going to produce. I mean, that's what an individual one looks like. Set one of these right on a point, and it tells you on your mimic panel, if it's green, you've set that point to main. If you've set it to yellow, it's set to branch, and you know that siding has nothing in it. But if it's red, then it's set to branch, but watch out, don't try to put another train in there because the siding is already occupied. That one LED can have multiple colours to indicate different situations if you're able to do programming. I say another discussion entirely, but worthwhile maybe.
And with that, it concludes the look not at how LEDs work, but how we can use them on our layouts to best effect.